Hello and welcome to the Defusal module series. In this series, I go through each module in Defusal and show you how to disarm them. In this case, we will be looking at the logic module, which has a pink glowing highlight, as well as three switches, an input, a green submit button, and a light at the top of the module, which will change depending on the orientation of the switches. So, let's look at this first module. We can see that all the switches are down, and as such, we can say that 0, 0, 0, or off, 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 is equal to 0. We can then turn this first switch on, which turns the whole circuit on, so we know 0, 0, 1, off, off, on, is equal to 1. It's on. We can then turn the middle switch on and the last switch off to get 0, 1, 0, which is 1. We can do the same for 0, 1, 1, which is 1. And then we'll do it again with this switch on. 1, 0, 0 is off. 1, 0, 1 is on. 1, 1, 0 is off. And all the switches on is on. 1, 1, 1 equals 1. We can then start applying boolean rules to this. So, the first thing we look at is there any pattern? Well, there are a couple patterns. The one I will look at is the C, which is this third column. If the third column is on, the light is always on. So we can say C equals on or off. We can say that part of the condition is C. So we can say that C tells us whether the light is on or off, and we would be almost correct. However, we can see that there are some cases where C is off, but the light is on. So we can say that C is on, or C is off, or C is off. When C is off, we look at these four. C is off, C is off, C is off, and C is off. In these cases, we can see it's only on if A is off and B is on. We can say, or C is off and B is on and A is off. We can then write this with boolean rules. So C, or, which we use this pipe symbol for, not C. And then in this case, I'm going to use a star to represent and for the time being. Otherwise, you end up with this being squished together, and it can be a bit hard to tell. Actually, no. Yes, I will use a star. So, you can see, not A. So you can see, A is off, so not A. B is on, so B. And C is off, so not C. Or just C. However, we can actually use a trick. Since here we are saying C is on, if C is on, we don't care about this half of the rule. So the only time we care about this half of the rule is if C is off. Therefore, this not C here does not matter, and we can get rid of it. You can see we now have C, or B and not A. Or C bar B times not A. We can then look, whoops, that is the wrong manual. We can then look at the logic. So we want C or B, not A. And if we look through these, we can see here. Now you'll notice it's swapped. So remember, if we swap this around, actually here, it uses plus. I will change this to plus for the others. In fact, I'll change it now to plus. So you can see this or C. And you can see this and this are the same. We've just swapped it around. B, A bar is the same as not A. And A bar B, and you can see there's no space in between. So this is the same as and. We can say A bar B is the same as B and not A. And we can see the plus for or, and we can see the C. So now we have our condition, which is A bar B plus C. And you'll notice if I get rid of the space and the brackets, this and this look very similar because they are the same condition. And we know this gives us NODEY. NODEY. Then hit submit and disarm the module. We can then get the condition for this one. In order to save time, I'm just going to write them all here ahead of time. And this is generally what you should be doing if you are disarming this module, is write these ahead of time. You can see we get 0, 1, 0, 1, 0, 0, 0, 1. So, first off, we can look here. In all of these cases, C is on. You can see here, C is on, here, C is on, and here, C is on. So we know it must be C and something. So let's look at the ones where C is true, or C is on. C is on, C is on, C is on, C is on. We can see it's only off when C is on if and. So we can see here, A is on, but B is off. Okay, A and not, A is off and B is on. Is that the right way around? No. A is on and B is off. You can see, if C is on, and A, and this is not true, then the light turns on. However, we can use quite a complicated rule, which is that not A and B equal to not A or not B. So you can see we moved the not inwards. If this was not, if we had A and not B, we'd have not A or B. If the not is here, we have not A. Well, first we'll rearrange this to C and not A or and not B and not B, and we can then use this rule to pull it out. So we have C and not A or B. If you check this with each of these, you will see that it works. We can then simply simplify this down. Or it's written as a plus with C and not A plus B. And again, I'll just put some enters so you can see what we're doing. We can then change not to an exclamation mark to make it easier. And then we can get rid of the word and. Get C, not or B. Now obviously, the module uses A bar. So we are looking for C times A bar plus B, which we can see here as C, A bar plus B, or loop. So we can put loop in and solve the module. We will do this again for the third one. So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 101, 1, 1, 0, 1, 1, 1. And I'll just add these ahead of time, just so I'm not trying to scramble it in. So 0, 1, 1, 1, and then 0, 1, 1, 0. You can see here, if this is on, if this is off, oh, sorry. Oh, this is actually the same. You can see here, we get the same table. Therefore, I don't have to do any of the logic here. We can just go straight to the end because it is nodey, which will actually save us a bit of time. And my worry here is that... Okay, no, they are different. So let's look at this fourth module. Actually, I'll copy paste this down the line for the fifth module, just to save some time. So off, so 0, 0. Off, so 0, 0. On, so 1, 1. On, so 1, 1. Well, we can see if A is on, the light is on. And if we check that, it works for all of them. So we don't need to do anything else. We can just look for A. And we know A is vector, as we can see there. So we can just type in vector and hit submit. Then we can look at this last module and see the same. So you see 0, 1, 0, 1. And my worry is this is the same. 0, 0, 0, 1. And again, if we look up, these two modules have the same pattern. So I don't need to do any logic. I know we have this, which I know from earlier was loop, I believe. We'll check now. Loop, yeah. So, the one thing I will do before we finish is quickly go through all the Boolean rules, just in case you don't know them. So, A and, so, A, B or C is equal to A or B, A or C. We can see here, we can multiply. What we can do is we can do each part separately. This is kind of the same way you would do it in normal mathematics, in that you can expand. You can see here, instead of doing A, B or C, we're doing, oh sorry, should be AB or AC. So A bracket B or C is the same as AB or AC, because we do these two together, and then all of them. This is the same, and obviously you can go backwards. So so BA or BC is equal to B, A or C, and then A or 0 is A and 0 equals 0. A and 1 equals 1, A plus 1 equals 1. So we have these rules, and obviously the rule I mentioned earlier, so not A and B is equal to not A or not B, and obviously vice versa, or. So not A or B is equal to not A and not B. And the last rule is the conditional rule. So if you have A or not A plus whatever, this is equal to A or whatever. You can see if you have A on one side and not A on the other side, you don't need to repeat the not A. So we can separate like this. And this module is fairly difficult to explain, so it's one of those where you might find some use in going through Boolean algebra in general if you're having trouble with this module. But the important things are to try and find a pattern. If there's no pattern, so if there's just 3 of them that look kind of random, it's probably array. Because it's pretty rare that you have 3 on. And we can use this rule to rewrite shard, stuff like shard. So if you have A or B or C, this is equal to not. We can actually write this as not A, or not B, or not C, because two nots cancel out. And then we can use this rule here. As we can take not A, and not B, and not C. Now, if you do this with null, you'd get the opposite. So null is actually not A and B and C. And you can see here that if you have something or something or something, you can put a not before it and flip them all to make your life a bit easier. Apart from that, there isn't really a whole lot I can help you with on this module. And you might find it easier to do boolean algebra outside the Defusal and come back. Apart from that, I will finish by saying, as always, that this is how you disarm the logic module.